I'll do one example from the trigonometry practice problems. I expect this is review, so this is just to get your minds back to it. Most students know this from their early exposure to trigonometry. For a right angle, the sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Number 2 looks like we know this angle is 24 degrees. We see its opposite side, and we want to know the hypotenuse. So the sine involves those three things. So a sine arrangement will allow the unknown hypotenuse to be solved. The sine of 24 degrees is the opposite side divided by the hypotenuse. I would like to isolate h and solve for h, so I'll multiply both sides by h, and it goes away there, and then I will divide both sides by the sine of 24 degrees. I think I need the sine there, and it cancels there, and I'm left with the expression h equals 4.6 meters divided by the sine of 24 degrees. On the trig table, 24 degrees has a sine of 0.407. So 4.6 meters divided by 0.407 is 11.3 meters. So that is the unknown hypotenuse on this triangle. Let's look at number 3. These problems, for some reason, can trouble students, the ones that involve a plane and wind. Just look at the triangle and think of it as just a straight trigonometry problem. We know this side has a value of 65. The units are meters per second because it's talking about velocity. Just work with 65, and this side is 16. Again, the units are meters per second, but let's just go along for the ride. And it looks like we do not know theta in this case, and we do not know the hypotenuse. I see for theta, I have the opposite and the adjacent sides, which makes me think of tangent, and so I can get theta by using inverse tangent. Inverse tangent of 16 over 65 is 13.8 degrees, so that's the angle there. To solve for h, I have a couple choices. I can use trigonometry and a sine or cosine. I'm going to use the Pythagorean theorem here and solve for h because the hypotenuse squared equals the opposite side squared plus the adjacent side squared. And the hypotenuse turns out to be 66.9 meters per second to match the units that we have here and here.